software-defined vehicles session. And yeah, so I'm here with my two friends, Sagar from the Rivals team, but they get a chance to introduce themselves, right? And then my friend Piyush, which I do remember your name, you don't have to say it. But yeah, so we made a TechGene event last year, and so I get them to introduce. I work in the CTO office, I look after all things Edge, and yeah, and cars are pretty fun Edge vehicle Edge devices, so I thought why not, okay? So Sagar, do you want to do a quick intro of yours, and then Piyush?
Yeah, I'm basically working in vehicle operating system team. So yeah, that's all. Piyush, you can introduce yourself.
Hey, hi. So this is Piyush. We have been working on in-vehicle operating system, and we are trying to see how an application developer can easily develop application on in-vehicle operating systems. In open source world, there is a lot of work which is happening for in-vehicle development, software-defined vehicles, and AutoSD is the component which is playing crucial part. We are trying to integrate a lot of open source technologies with AutoSD. So we'll see what application we are trying to develop. So you want to start?
Yeah, maybe Andres, you can start with the software-defined vehicle introduction.
Me, yeah? Okay, I'll take it away. Okay, so it's a very exciting industry at the moment to be on, and I don't know whether, has anyone seen the latest software-defined vehicle kind of announcements in India and the car-related treasures? Tesla? Yeah, Tesla. Now I'm talking about the APEC cars, right? So it's funny because we had this conversation and there's a lot of focus on the Beamers, and I'm actually, in my hometown, BMW has a manufacturing plant, so I'm very close to this brand. My dad, I think, drove Beamers his entire life, but I believe that the revolution in automotive is actually happening in Asia Pacific, right? And so the whole industry is kind of on the verge, because what we're seeing now, currently there's a lack of standardization, so you have varying hardware and software requirements, right? You have a lot is running on ARM at the moment, shifting customer expectations. We want more like personalization, app services. In my car, I've got an EV, I press a button and it does lower the windows, the roof shade, the temperature, the fan speed, the changes the music. So this is kind of, it's kind of hard then to go into an older vehicle, right? And then fragmented development in data. A lot of, and Saga is looking at things like what the data format's going to look like and how open source is actually addressing this, but proprietary software, data accessibility, and then obviously specialized talent need. Emerging tech stacks require specialty resources. Are you aware that BMW and Tata Technology just started a joint venture in India? Right? I think it covers Pune and Bangalore, right? Yes. So they also know where the future is, right? That's pretty awesome. And so the negative consequences are the high cost of initial deployment, long time to revenue, and smaller profit margins, and also hard to change, right? So this is the automotive industry. If you want to say, if you want to add something, feel free, right? So from an architecture perspective, you see kind of the traditional architecture on the left-hand side. We got your ECUs. I never can remember what that's electronic compute unit, is it? Piyush? I think.
You can keep it compute, yeah.
Yeah.
High performance
And,
computing.
yeah, and sorry?
And HPC.
Yeah, exactly. So on the old, it's like, do you have purpose-built, as we said just in the previous slide, from an architecture perspective, that's how purpose-built hardware and software looks like, right? So, and in a in a cloud-native software-defined way, we now going more. It's not a client-server type thing, but it is a little bit, right? You got high-performance platform and the and computing platform, and the apps run on that, and you still have like smaller ECUs, for example, right? So that's kind of where the architecture evolves into, and this is interesting because it's a combination now of what we know in cloud-native kind of environments and how we connect it to in-vehicle, and that's kind of what we as Red Hat or AutoSD as an upstream project is doing. But at the end of the day, there's again the entire software development lifecycle, right? And that also means that, say, if RISC-V makes it into the car, then you will have to deploy or compile your code, your functionality into RISC-V compliant binaries or ARM as such, right? So, and I also know that x86 providers such as Intel, they also have their development efforts where they actually try to move into the automotive space as well. And so cloud, standard, right, connected vehicle platform and operation center, and then testing and development. And it becomes pretty complex and pretty highly important if you think you have all those applications running in your car, and they control things like your airbag and your driver assist. Your advanced ADAS is a term, advanced driver assistance systems, or lane departure warning, adaptive cruise control, driver fatigue monitoring, right? All those really important functions that keep you safely on the road. So there is obviously it's different in terms of life-threatening comparing to your banking application, right? And then so the open road runs on Linux, so that's kind of the vision we all work on, right? Faster time to market, the power of many, that's the open source mantra, right? Modern tool chains, continuous certification, optimized development, common platform, increased usability, and a broad software talent pool, and then long-term relevancy, ongoing updates, new business models, long-time support as well, right? From companies like Red Hat or whoever. And Red Hat is not the only one playing in that field, right? There's a lot of startups and companies that basically support the software-defined vehicle mantra. So now here's a bit of a what day is it? Friday afternoon quiz. So if you look at this box down here, right? We agree we all want to deliver an open, safe, and secure Linux-based in-vehicle operating system. Our operating system will support these domains functions. Now think about you as a developer. What is kind of what can you see as the difference between the top three, ADAS, which stands for Advanced Driver Assistance Systems, the digital cockpit or the in-vehicle infotainment, and the body control, like ABS, for example, connected to the connectivity and telemetry part? Can you think of anything? Sorry? So what do you need if you're a developer and you want to develop on those fields? You have the top three and you've got the last one. Can you think of anything?
I think it's related to all of the other talks that we've had. Telemetry is one of them.
Yeah, exactly. So telemetry is important, obviously, right? But the beauty is, and that's why...
That's the one we're going to cover it.
Exactly.
Specifically that.
And I learned that just yesterday from Sagar. That's why I want to repeat it. But so for ADAS, digital cockpit, body control, you need actually those devices, right? To you can't, like, I'm not aware of any like simulators, right, that give you.
Sensors.
Sorry. Sensors. Yeah, exactly. But also like the digital cockpit, right? I don't know of any virtual or mock-up type environments, right? That do ABS kind of. It's not readily available. What I'm saying, right? It's not that I can just spin up my KVM and simulate an edge device that runs whatever, like a camera on it, right? So this is why today we're going to focus on connectivity and telemetry, and everybody in this room can actually try this out and work on that, right? And Sagar and Piyush will go further into depth. So, can you do me a favor and explain this, because there's a very simple diagram, but there is actually a lot to it. Like, what is a QM app? ASIL stands for, well, ASIL-B is basically the automotive safety integrated layer.
Levels.
Levels.
I mean, basically there are
So
different types of applications are there. You can see ASLB applications, then QM applications. So I mean, basically the QM applications are, you can imagine like the music systems, or the non-critical applications are the QM applications, and the ASLB applications are the safety related applications. So those can be deployed in a different way. You can see in the container or without container. Guest OS, you can see the QM app in the guest OS. So that is the Android automotive applications. So yeah, so that is deployed on top of this is the Redhat in-vehicle OS. This is, I mean, we'll be discussing more about this AutoSD. That is the open source community variant. Yeah, but that's the approach. Yeah.
So ASIL has 4 layers: ASIL A, B, C, and D. D is the highest, and that's something like airbags and stuff, right? That can't fail, or even maybe ABS or so, maybe C, right? But for us as Red Hat at this stage, or as an open source software defined vehicle community, we targeting ASIL B, right? And that's kind of ADAS ID, Advanced Driver Assistance System, what I said earlier, fatigue monitoring, lane departure warning and stuff like that. And yeah, I mean, this is kind of where we're trying to bring the world together. What we've done in the enterprise, we now want to bring to the defined software-defined vehicle, off-board and on-board. I believe that's important. One of the big topics is always over-the-air update, updating your vehicle. But obviously, as you can see, if you have many different versions of software running in millions of edge devices, cars that are driving on the road, the requirements are pretty full on, right, in terms of ensuring that this is all working. So I don't know whether you remember, years ago we had a big reference case where Volkswagen worked with Red Hat, where the Open Innovation Labs team actually went to Volkswagen, and they basically replaced the hardware in the loop testing with software in the loop testing, where they deployed all the different software components as containers on OpenShift and tested the things like, all those ADAS AD functions, for example, in a virtual environment. So the car wasn't on the road, which it usually is, right? They let that software drive in a virtual environment, and that was pretty awesome. And that's kind of what we're trying to do here, connecting really the developer experience and the testing, like we know it from cloud-native applications, all the way to the in-vehicle experience. Okay? And yeah, that's pretty much a summary of what I just said. And with that, I'll hand over to you, gentlemen. Is that okay? Oh, one more slide. So when I was in Mumbai a few months ago, I met with Tata Motors and Tata Elxsi, and kind of from a simplified architecture perspective, this is what those OEMs, so we call car manufacturers OEMs in our world, right? So the original equipment manufacturers. And they want that startup community and ecosystem to thrive. They want those players come in and help them innovate their vehicles and bring it to the next level. And that's again a great platform play where you have a standardized API like an OpenShift API, for example, or Kubernetes API, and then you have your third-party innovation providers, whatever it is, right? What I just mentioned earlier, deploying their code and their innovations to that platform. You build it, and that could be an x86 development over here, and the target platform could be then ARM, for example, or RISC-V, right? That's kind of a very simplified version of kind of where whole ecosystem can basically participate in developing the vehicle 4.0 sort of vision, as I said it here on that slide deck. Okay, awesome. Now let's go to the CO2 part of today.
Yeah, so this is our example application. So before starting with this application, so let me just know more about, are there any application developers present over here? Okay. Any other application developer? Maybe for any platform, that is fine. Okay, so could you tell me, yeah, so could you tell me for which platform we are developing applications? What is the target platform you are developing applications for? What is the deployment environment? Is it mobile application or any cloud application? Cloud application, right? Okay. So, so basically, we'll be developing application for the vehicle, that is the edge device we can imagine. So, but what is different over here? There are many, car applications are there, right? The Android automotive applications are there. So what is different here? So, and where we are going to deploy those applications inside a car. So let me go to the previous slide. Just a moment. Yeah, so this is the architecture. So if you look into any vehicle right now, which are present in the market right now, so you can see there are multiple issues over here. Those are the small computing unit you can imagine. This is the left one, and the right one is this is the new architecture which is going to come in future. So you can see this HPC platform 1 and 2 are there. This is just, I mean, the integrated ECUs are there in a high performance computing in that way. So we'll be developing the applications for these HPCs. So those computing units would be there inside the vehicle. So it is, I mean, you might be seeing those applications which are in front of your instrument cluster, right? Your music application or anything in Android Automotive or Android Auto. So, but these are the applications which we are trying to deploy it on HPCs. Those are basically, you can see the telematics unit and yeah. So yeah, so yeah. Yeah. It's a generic term, of course. I mean, there are different platforms, different silicon providers are there in the market. So it's a generic term, yeah.
So it's basically way more powerful than the ECU.
Yeah, that's way more platform, yeah. So that is the purpose of software-defined vehicle. I mean, it empowers the future applications of connected vehicles. Mhm. Okay. Okay, let me go to this example application. So for development of any application, so could anyone can tell me what do you need to develop an application? Anything, a platform, a framework you need, right? So you can see this is our framework. So you can see the ID is there, onboard is there, offboard. There are 3 sections over here. So in the ID sections, we'll be developing the applications by using those frameworks particularly. So you can see there are many components over here. I'll give you a short description about all of those components. Not all, basically, you don't need all of those components. You just need this Velocitas, VS Code to get started with your application coding. That's all you need. So here you can see GitHub, VS Code, Podman, Cuxa, Velocitas, Mosquito. These are the basic components will be needed to develop an in-vehicle application. So let me start with AutoSD. So this is basic. Okay, let me start with Velocitas. The sequence is not correct. Sorry, I'll start with Velocitas. Yeah. So Velocitas is just, I mean, SDK that needs to be integrated with VS Code to develop the application. You can develop your application in Python or maybe in C++. And yeah, Rust is the future, but right now we are focused much into this C++ and Python. So this can be integrated in VS Code, that's all. You just need few commands to invoke. Yeah, so this is Mosquito. Why this is required? To develop in-vehicle application, in a connected vehicle platform, you need some protocol, right, to connect with the cloud to the V2X, I mean, to the infra, right? So for that, you need some kind of protocol that is MQTT, of course. So this is the Mosquito is the MQTT broker. So you can use a Mosquito. There are a lot of many brokers out there in the market, but this is the open source and is a good one. So we are using this Mosquito as a data broker. Okay, let me. Okay, so this is Bluechy. So what Bluechy is basically, if you are developing application for in a multi-node environment, let's say there are multiple nodes are there and your application, you are developing multiple application, you just need to manage those applications, then you can use Bluechy. This is of course, I mean, it's an Eclipse project, but I mean, Red Hat is the major contributor, and I mean, Red Hat initiated this project, Bluechy. Yeah, basically, I mean, it's the replacement of Kubernetes. I mean, not Kubernetes exactly. I mean, we're not going to use Kubernetes because that is very heavyweight. And again, there are some challenges are there in Kubernetes. Bluechy is basically systemd only. I mean, it is the abstraction. The abstraction is systemd. Yeah. So yeah, then yeah. So we covered this ID section. That what we need to develop an application. Then the next part is how to deploy those applications. I mean, of course, we need some deployment environment, right? So to test our applications. And we need some test framework as well, that how our application is working or not. So let me cover those things. Okay, let's start with CentOS. Yeah, so this is AutoSD, basically the community variant of Red Hat in-vehicle operating system. So there, I mean, much of the community contributions are made, and we're going to deploy our application on top of AutoSD. So there are some customization is required. So we'll be providing those images, those custom images we'll be providing, so that you can deploy your application on top of AutoSD. So those are some, because AutoSD is not your generic operating system like maybe in generic Linux or generic Windows. Those, I mean, there you can just run your application, right? Directly you can hit those run command. But here that won't be happening. So here what we are going to do is, it is a kind of customized or custom OS, you can imagine, like a immutable OS. So what you can do is, once your application is developed, then you just need to integrate those application in AutoSD. There are some processes, I mean, the topic is very vast, so you can go to those links, you can check how to, once your application is developed, then you can integrate those application in AutoSD. So once the deployment is done, then you need to test your application, whether it is working or not. So, I mean, in any operating system, I mean, there are many middlewares or many abstractions are there, right? So here our abstraction provides, the Kuxa is the abstraction that Kuxa is providing. So we don't need to dig much into this Kuxa, but we need the Kuxa is providing some CLI tool to test our applications, because we need to interact with our vehicle component side. So we need to know that what are the components, what are the signals, so that we can test. So this is one example of testing. Yeah. So you can see, once your application is developed, then you can test your application. So there are some commands are there. It is already there in Kuxa CLI. Is the get vehicle speed. One command is there, so you can just run your command to get your data, whatever you have written in your code. So whether that signal is going or not, whether the data is coming or not. So you can check those data by using those commands. So there are many commands out there. You can just I mean, hit some help command, then you would be getting to know the list of commands, how to interact with your applications. So yeah, so those are the basics. So yes, Piyush, maybe you can cover that, what are the progress, and yeah.
Just can you go to the framework slide? Yeah. I just want to talk about the beauty of this slide. It looks very complex, but as Andreas was saying, that simplicity of development, how we can simplify the development of application, particularly for AutoSD. So if you can see in this IDE section, we are developing application, of course, in VS Code. And whatever development happens over here, you can either push your code to Git. Git will generate the artifacts. It has some Git actions. It will generate the artifacts. Or Velocitas also has the VS Code also has the functionality of remote development. So we are particularly using Dev containers in this case. You can directly SSH to the Raspberry Pi or your target hardware, whatever it is, which has the AutoSD or particularly in this case AutoSD installed. You can do the complete development. Like when you trigger the dev container, it gets installed on the AutoSD on the target hardware, and it directly gets built over there. And then you can run it. You can actually test it. In this case, it is a bit different. We'll need CentOS in this case to do initial development, but this is the simplicity which we have bought with the use of VS Code and all these frameworks which are over here. And up till now we have developed the we have been able to completely generate the application on the target platform, and once it is pushed, you can directly use it, and then you can use this complete framework to develop your own application. And in this case, we are trying to get some data from the application. Like there is OBD port over there. So from direct, if this Raspberry Pi hardware is connected to your OBD port and Raspberry Pi is running the AutoSD, you can directly get data from your car and then send it to the telemetry unit, and then you can just make sense of that data. On the right side, we are shown off-board activities where we'll actually, on the dashboard, we'll see all the data. It can be done on board as well, but this is one small example. We are trying to showcase that what we can achieve by using AutoSD, by using these the open source technologies which are already there. So we have integrated everything and tried to simplify the development cycle. So yeah, once this repository is ready, this application is ready, we will be pushing it on Git, and then you will be able to use it. We will share the QR code with you. You will be able to use it and develop your own application on it.
Yeah, so maybe Andres, you can cover the output side.
Thanks. I mean, we all know what those kind of components look like. Kubernetes, right? So from a Red Hat perspective, obviously OpenShift, but Kubernetes is the standard the open source standard we rely on. And Kafka is, everybody I guess is familiar with what Kafka is. InfluxDB for storage, Grafana, the dashboard. We covered that in so many, as you said, right? We covered that in so many previous sessions. And the beauty is that those are well-known kind of components, right? And it's a mix of what I like about is that the back end here is components that have been around for a long time, open source projects, right? And we know they're stable. What we now can focus on is basically the in-vehicle and the IDE part of that architecture, right? Even Mosquito has been around forever, and now we can focus even on, not even that, now we can focus on Cuxa, Velocitas, and really the AutoSD kind of program. Yeah, that's it from me. Sagar, do you want to?
Yeah, so in our example application, what we are doing is we are fetching some data from the vehicle. Those are the OBD data. And we'll be filtering out those data and sending it to the cloud for the further analysis. So this use case is basically for this carbon footprint. So we'll be evaluating, the carbon footprint of any vehicle. So that is the example scenario. So you can develop your own applications. So this is just a framework we are suggesting. So yeah. So let me share some. Yeah. So these are our future topics. Maybe Andreas, you would like to cover.
Have you got a slide with the signals that are coming out of the cars in that deck? No, if you not, that's fine. Because if you look at the project, they actually have defined what the data structure looks like that comes out of the vehicles, and that's kind of the very important base step, right? So that every OEM agrees of what that data looks like, right? That's coming out. No, I'm talking about the one on the Git repo we looked at a few days ago. Remember? Yeah, exactly. Maybe bring that up. I'm just gonna carry that out quickly, and then you'll find it quickly, right? Just to give the audience a bit of an idea how this looks like. But yeah, future topics. I mean, I said before in the hotel thing, you need to always have AI at least once, and so same here, right? Federated learning. Are you guys familiar with what federated learning is? So federated learning basically is, usually we think we need to carry all the data to a central location, train the model, and then deploy the model. Federated learning is different. You basically train the model at the edge, so in that case on the vehicle, and then the data, and that could be data volume related or data privacy related or compliance related. So you basically train the model at the edge, in that case on the car, and then you just share the updated model parameters and weights up to an aggregation layer, and then you fuse that updates, you fuse them together in the model, and then you push the model back out. So that's something that we looked at. I just did a global research with a research company. Federated learning in automotive is actually the largest use case for federated learning. So I think that's definitely interesting. OTel, obviously, open telemetry, right, to connect the all the signals, and then the model deployment as part of the federated learning approach. Did you want to show those signals quickly, or? Sorry, I'm putting him on the spot here because he didn't expect that. Oh, actually, I don't know. We probably don't have internet. Can you type that? Can you type the thing? Maybe it's in cache or in a tab open. Can you type the? Do you remember the main, the domain? What's the domain again?
I think it was, he's talking about signals, right?
Yes.
Signals. VSS signals maybe.
Yes, VSS
VSS
signals.
signals.
Well, just VSS. Type
Just
in
type
VSS.
over there.
No, maybe it's a tab open. I have about 300 tabs open, so if I'm lucky. If the demo gods, no, the demo god not with me. Anyway, why don't you? Do you have any questions in the meantime? Because then
Yeah, and
Internet में
where is that?
did you want to go to the?
Yeah, so where is it? Our slide? Oh, it was in the Chrome browser itself.
So what are we looking for?
Yeah, the our slides. It itself has those signals in small format. So if you go to this section, this 19th, yeah, these are the actual signals, but in very small form.
Yeah,
This
yeah.
is very small example.
This list we can find it in GitHub, but anyway.
Yeah, hold on. I'm just maybe. Do you have any? Are there any questions?
Yeah, in the meantime, if you have any questions, please go ahead. Yeah, go ahead.
You mentioned you were going to train the data on the edge. So is it better to train the data on the cloud and just collect the data on the edge?
It depends on the use case. Federated learning, the definition of federated learning is that the training, and as I said, it depends on the use case, right? If you have too much data, manufacturing as well, right? The terabytes of data. If you have too much data or the data privacy concerns, then you basically change to the training the model in edge locations. Great question, thank you.
Anything else you want to know?
In a second, yep.
So what he's trying to showcase is the signals. This is basically signal specification. When we are going to develop application for a car, so we really don't want to know which car we are developing for most of the times. The final developer who is developing the application, he should not be knowing, I mean, he doesn't need to care what car he is developing the application for. So there are some specifications which have been created for development of car applications. So the hierarchy of signals we are going to see right now, this is what it is going to look like. And yes, or Sagar, you want to talk on this one? Yeah.
Yeah, basically, I mean, these are the OBD signals which we just talked. So, so these are the signals we'll be fetching from the vehicle, and we can do whatever we want. I mean, just this is our example use case. That is the carbon footprint. What we are, I mean, that is simple example, but by using these signals, you can do whatever you want. These are OBD signals, but in this repository, you could find different signals from any other HPCs, right? Those are maybe ADAS or maybe something else, yeah.
So yeah, that's what I meant earlier, right? This is a foundation for anything you want to do in terms of workload, right? You know, is the engine on? What's the RPMs of the engine? What's the temperature of the engine? You know, what else is on? Is the aircon on? Is the aircon off? That's kind of what those signals are all about, right? And that's kind of a very fundamental step. I hope, the reason I'm showing that is because I hope, you know, you can draw all those pretty pictures and lines on an architecture diagram, but this is also kind of very important, right? And it's already been progressed. I mean, I'm pretty sure it's not complete, but I'm also pretty sure it wasn't easy to think about across all the OEMs what those data structures would look like and what you want to get out of a vehicle, right? So software-defined vehicle, that's where it starts, I guess, right? Okay, we out of time. Any more questions?
So even today we will have those softwares who will be reading these signals, right? So are we building an open source solution? Because, so what is so unique you are bringing in this?
Sagar, do you want to take that? It's the open source ecosystem, right? Driving basically another part of our daily life that is going to be rewritten by open source, like what we do in manufacturing, everything like Siemens, Rockwell, Allen Bradley's, like that. That's kind of where software takes over, and in the same fashion we do it in the automotive world with Auto SD, right? Does it answer the question?
I mean, your question is more about the complete ecosystem, or it is more about the operating system?
So I think there will be, even today there will be a solution because there are many tasks who are already utilizing all this data, right? So are we, so as a solution, are we building an open source solution that is so unique about
Yeah,
it? And then-
that's the unique part. I mean, the Auto SD you can see from Red Hat. So that is the open source solution from Red Hat, and that is specifically for this automotive HPCs. I mean, you could heard of QNX and other operating systems, right? But this is the open source solution what Red Hat is bringing to the table.
Is that what we noticed over here, the VSS specification which we are going to use in this case, we don't really need to take care of, like Yamaha bikes nowadays. You can just connect Bluetooth and you can get the data from OBD. Same thing it is doing. But that will work only on a Yamaha because it is meant for that bike, right? It is talking to that bike specifically and it is getting data from it. So once you use VSS specifications and the framework we have showcased, you don't need to really worry about where it will be implemented. The final application, where it will be, which car it will be implemented on. It will just, work. It will just understand the hierarchy of signals and it will start working.